So we finished up the last class, if you remember, that for nozzle flow again, or flow through nozzle, we have seen that P0 over P is equals to 0.528, or P by P0 is equals to 1.893. What it implies? It implies that we said this was the nozzle, right? And here the pressure was P, specific volume was V, small velocity was small v, and there at the tip the pressure was P0, volume was V0, specific volume was V0, and velocity was V0, right? And area here, if it is A, here A0, right? So this was the case. In that case, the pressure ratio, this is tip to the inside, or we can say outlet to inlet, right? This is pressure ratio outlet to inlet or tip to the inside. That is coming to be equals to 0.528. Now the question was, we slept here. I mean, it was hurriedly finished. If we recapitulate a little, that we had this relation, that x is equals to 2 by gamma plus 1 into 2 by gamma plus 1 to the power gamma by gamma minus 1, right? So we said this, that x was equals to P0 by P, right? So P0 by P was equals to 2 by gamma plus 1 to the power gamma by gamma minus 1, right? Now this was so. Now we said for a diatomic gas, the value of gamma is equals to 1.4. If it is assumed, then if we write P0 by P is equals to 2 by 1.4 plus 1 to the power 1.4 by 1.4 minus 1, this becomes equals to 2 by 2.4 to the power 1.4 divided by 0.4. If we look at this calculator, right? If we look at the calculator, if we look at the calculator, is not you are not getting calculator here, right? We are not getting calculator here. So okay, if we don't get calculator, then it can be that if you can check also that the calculator is like that. Okay, in the accessories calculator is there, and we can fix up. Yeah, we got the calculator, and if we take scientific calculator, then no need scientific, but still we have some more. So then we have 2 by 2 by 2.4, right? So it is, and they are 1.4 by 0.4. So we write 2 by 2.4, right? This is equals to 0.833 to the power, so x to the power y to the power, we write 1.4 by 4, 1.4 divided by 0.4. So this comes to this, and if we do that, it becomes 0.528, right? This is what is coming, 0.528. So that is what we had written, that 2 by this is equals to 0.528, and if you do the inverse of this, it is 1.89, say 3 equal to 1, not this, then P by P0, that becomes 1.893, right? So this is a typical value. This value we have to remember. Let us take out this calculator once again. So if we enlarge it, so this has a typical value. Why? This P0 by P, that is pressure at the tip to the pressure at the inlet, this ratio is 0.528. And if you remember that we said that when the discharge is maximum, for that the condition was dW dP0 is 0, right? So if dW dP0 is 0 corresponds to a maximum velocity, then the pressure ratio comes to, for a diatomic gas rather, whose value is 1.4 gamma, that heat capacity ratio, right? If that is 1.4, then the pressure ratio from the tip to the inlet is, pressure ratio for tip to inlet is 0.528. That means if the pressure ratio between tip and the interior is, or outlet to inlet is 0.528, we can say the discharge is maximum. We can say that the discharge is maximum when the pressure ratio is P0 by P 0.528, that is outlet to inlet, or the reverse. If it is inlet to outlet, then also it can be said inlet to outlet is P by P0, that is equals to 1.893. So when the inlet to outlet pressure ratio is 1.893, then also we can say the discharge is maximum, right? So if pressure ratio is any 1.893 inlet to outlet or 0.528 outlet to inlet, then we can tell the discharge is maximum. Or for maximum discharge, the pressure ratio inlet to outlet has to be 1.893 or outlet to inlet has to be 0.528. Then only we can say the discharge is maximum, right? This we have to keep in mind. This is very helpful for finding out both discharge and the velocity at the tip, to find out that, right? For example, if we look at this problem, that a nozzle of 1.2 millimeter diameter with a coefficient of discharge of 0.91, this coefficient of discharge 0.91 is given by the manufacturer, is to deliver air from 3 atmosphere pressure to 2 atmosphere pressure at 35 degrees centigrade. Calculate the velocity, mass flow rate and maximum velocity and mass flow rate corresponding to the downstream pressure at a critical value, whatever it is. Assume molecular weight of air to be 28.97. So I repeat, it is a nozzle of 1.2 millimeter diameter with a coefficient of discharge of 0.91 is to deliver air from 3 atmosphere pressure to 2 atmosphere pressure at 35 degrees centigrade. Calculate the velocity, mass flow rate and the maximum velocity and mass flow rate corresponding to the downstream pressure at a critical value. Assume molecular weight of air to be 28.97. What do you understand by downstream pressure? So, if this is the upstream, then this is the downstream, right? So, at the tip is the downstream, and this corresponds to this P0, V0, capital V0 or specific volume at the tip 0 and or V0 or interior is A, P, V like that, right? So, if we solve this problem, then it comes that we know that V0 or velocity was under root 2 gamma P by gamma minus 1 into rho into 1 minus P0 over P to the power gamma minus 1 by gamma, right. So, now given rho we know is nothing but Pm by RT, right. From the problem given, it is 35 degrees centigrade, right. So, P was given at 3 atmosphere to 2 atmosphere, right. So, if we take 3 atmosphere, 3 into 101, 325 Pascal into its molecular weight is given 28.97 divided by the gamma R is 8314 and temperature given is 35. So, 273 plus 35 is nothing but 308. So, if we calculate this, then how much it comes? Let us see. We have kept a calculator. Yeah, we have kept the calculator here. So, if we multiply the 3 into 1, 3 into 101, 325 into 28.97, right, is equal to this divided by 8314, sorry, 8314 divided by 308, right, is equal to 26.99. Let us, I hope, redo the thing because we had cancelled it somehow. So, 3 into 101, 325 into 28.97 divided by 8314 into 308. So, this becomes this equal to 3.43. So, 3.4389, that means you can take 3.44, right, kg per meter cube, right. So, if we take this, then we can say that rho is so much, right, rho is so much. So, 3.44 kg per meter cube, and A0, that is the tip area, is nothing but pi d square by 4. D is given pi into 0.0012, that is 1.2 millimeter in whole square divided by 4. This becomes equals to pi into 0.0012 square is equal to so much divided by 4, that is equal to 1.1309. 1.1309 into 10 to the power minus 6, so much meter square, right? If this is so much, so you know that what is the rho and m. Therefore, V0 we can write is equal to under root 2 into 1.4 into pressure, if we take it with 3 into 101325, 3 kilopascal. So 3101325, gamma is 1.4 minus 1. Rho we have found out 3.44 into 1 minus P0 is 2, P is 3 to the power 1.4 minus 1 divided by 1.4, right? So, this if we see again through calculation how much it is, then we see it is 2 into 1.4 into 3 into 101325 divided by or is equal to divided by 1.4 minus 1, 1.4 minus 1 into 3.44, right? So, this is equals to this, right, and equal to under root of 618,553.779 into, we still have into 1, 2, 3, right? 1 minus, we have taken unnecessarily so many, right? 1 minus 2 by 3, right, to the power 1.4 minus 1, that is 0.4 by 1.4, 0.4 divided by 1.4, right? 0.4 divided by 1.4 is this much, right? So, if we close all is equal to this much, it is under square root. So, square root 260. So, it was 260.12, right, is equal to 260.12 meter per second. So, velocity has come to be so much. Now, we need to find out the discharge, right. So, W we have found seen is CD A0 to gamma P rho divided by gamma minus 1 into P0 minus by P to the power 2 by gamma minus P0 by P to the power gamma minus 1 by gamma. right? Gamma plus 1 by gamma, right? So, if we add the values now, CD is given already is 0.91, A0 we have found out 1.1309 10 to the power minus 4 under root 2 into 1.4 into 3 into 101325 into 3.44 divided by rho is 3.44, 1.4 minus 1, right? This times, right? This times 2 by 3 to the power 2 by 1.4 minus 2 by 3 to the power 1.4 plus 1 by 1.4, right? All under root. So, if we now again see how much is the discharge, then we start from there. 2 into 1.4 into 3 into 101,325 into 3.44, 3.44, right? This is so much divided by 1.4 minus 1, that is 0.4, right? So, that is 0.4 and this is equals to this, right, times, right. So, 1, 2, let us take then 2 by 3, that is 0.66, 2 by 3, 3, 3 to the power 2 by 1.4 to the power 2 by 1.4. This is equals to this much, right, 1.4, okay. So, this actually, if we close it here, then and we can write here also point. So, this minus, we have done that mistake, minus 2 divided by 3 to the power 1.4 plus 1, 2.4 by 1.4, 2.4 by 1.4, that is 14, right, this, right, this is equals to so much. Now, this is under root, right, under root into 10 x to the power minus 4 this, right, into 1.1309 is equals to this into 0.91 is equal to No, something wrong somewhere we have done. Actually, it should have come. This is equals to 0.000689 so much kg per second, right? And that should be equals to 2.48 kg per hour, right? So this is the discharge, right? So we have found out what is the discharge, what is the velocity, right? Next comes what is the velocity when the discharge is maximum, right? Now discharge becomes maximum only when, let us bring it down, discharge becomes maximum only when P0 by P that is equals to 0.528. So corresponding to P0 by P equals to 0.528, what is the velocity? That should be the maximum velocity, right? So we have seen that V0 was under root 2 gamma P rho by gamma minus 1, right? 2 gamma P rho or V, 2 gamma P by gamma minus 1, this was V, gamma PV or gamma P by rho, okay? This was that into 1 minus P0 by P, this to the power gamma plus 1 by gamma under critical. Now this P0 by P is when 0.528, that is called critical pressure ratio. This is called critical pressure ratio. So if the pressure ratio is 0.528, then that is outlet to inlet or exit to inlet, right? Then it is called critical pressure ratio. So that is denoted as CR. So P0 by P to the power gamma plus 1 by gamma, or this was no, not plus, this was minus, gamma minus 1 by gamma critical. So we write 2 into 1.4 into 3 into 101325 divided by 1.4 minus 1 into 3.44, right, into 1 minus P0 by P is 0.528 to the power 1.4 minus 1 by 1.4, right, this whole to the power half, right. So this if we calculate, then it comes to be 321.2 meter per second, right, 321.2 meter per second. That means under critical pressure ratio, the maximum velocity is 321.2 meter per second, right. So we can also write then the maximum discharge corresponding to the critical pressure ratio. So maximum discharge corresponding to the critical pressure ratio of P by P0 over P equals to 0.528. If that be true, then we can write W is equals to CD S0 under root 2 gamma P rho by gamma minus 1 into P0 by P to the power 2 by gamma under critical minus P0 by P to the power gamma plus 1 by gamma under critical, right. So this becomes 0.91 into 1.1309 into 10 to the power minus 4 under root 2 into 1.4 into 3 into 101325 into rho is 3.44 by 1.4 minus 1 into 0.528 to the power 2 by 1.4 minus 0.528 to the power 1.4 plus 1 by 1.4, right. So, this becomes equals to, if you calculate, then that comes to equals to 7.2058 10 to the power minus 4 kg per second. So, it is very small number in terms of hour, it will be 2.594 kg per hour. So, you see that the discharge maximum is 2.594, the velocity maximum is 321.2, normal discharge is 2.48, and here it is 2.594, right, 2.48 kg per hour, whereas it is 2.594 kg per hour, and the velocity was also found out to be 260.12, whereas maximum velocity 321 point something, 321.2. So, this way, if you calculate, if you find out the velocity at the discharge, velocity at the tip corresponding discharge, and maximum velocity corresponding to maximum discharge, that comes under critical pressure ratio, that is P0 by P is equal to 0.528, right. Thank you.